Hey, it's Matt with an Uplink Tech Spot. So I've set up a scenario to demonstrate how to do network performance testing across distributed applications. So if you're an architect, this might be something to consider to include in your standard builds as you're deploying applications either in the cloud or in your private data centers. And so we've got a graphic here that kind of demonstrates the idea here. And so as you can see, it's a pretty simple layout, really common. I think you'd see something very similar to this design in most enterprises. So we've got an order application and a quote application that are tied together, and they both have a database. So we get a call from the users, and they say, hey, the order application's slow. And so we need to figure out where the slow link is so then we can start troubleshooting it. Well, with tightly integrated systems that bring the high degree of business value, what comes with that is a large number of a larger complexity in terms of the number of network links. So Linux has this really cool command, IP or iperf3. So imagine it's kind of like doing a speed test between your nodes. So it's pretty sweet. And so I'm going to demonstrate using that now. So for this first link, I'm simulating as I'm from like an end user system to the order application. I'm going to fire this off. What it does is it fires off a speed test. It fires off 10, like a 10-second speed test. And so here you can see for this first link to the order application, we're getting just under a gigabit per second traffic, which is right around what we'd expect. So we're expecting a gigabit link here, and we're getting 920, 917. Now with the quote app, let's see what we get to the quote app. We're seeing about the same. So we're expecting a gigabit link, and we're running right around 900 megabits. And this isn't anything that's going to say, hey, that's the problem. So now let's jump over to the order application. Now I'm testing this link from the order application to the order database. So we're going to run that one. Wow, this one rocks. Okay, we obviously have a lot of bandwidth here. This is showing up. The key column here is this bandwidth column. This kind of gives you the quick reference number. See, we're showing almost a 10 gigabit throughput there. So that's awesome. We're getting great throughput from the order app to the database. Now, let's do a quick check from the order app to the quote app to see if maybe it's the link between the systems because they communicate and share information. And so for this, we're seeing this is about what we'd expect because we understand that, link to be about a gigabit, and we're seeing just over 900 megabits. Now in the quote, let's do the other direction. Let's go from the quote app to the order app. Looks pretty healthy. 900, again, just over 900. So that leaves this last link from the quote app to the quote DB. Fire this off. Oh, not good. So here we were expecting something more along the lines of a gigabit or 10 gigabit, and we're getting something really choppy from 2 megs up to 94 megs, and it averaged out to be about 64. So now we've been able to identify exactly which link we need to go look at. And this just highlights, some of the challenges with distributed applications is, the user's reporting a problem with the order application, but the issue is really with the quote app talking to its quote database. Now, just for grins, we're going to see what is the bandwidth locally. So this is another cool piece with this. The command is you can, get a sense of what the backplane is. As you can see, running on this local hardware, and this isn't like a super beefy system at all. This is an i5, and we're getting just about 70 gigabits of backplane through here, just connecting locally through the system. So definitely, super fast to stay local when you can. This is just something interesting to note. One last piece on the iperf command. You can also output the command into JSON. So this is something you could set up to run on a periodic timer, grab the files, dump it into, an Elasticsearch or, some other monitoring dashboard and kind of get a sense of your critical links. So it makes it easy to kind of parse the data. You don't need to write a custom parser for that. So let's show what that looks like real quick. Give it the old -J command. Now when it runs with the JSON mode, it doesn't give you kind of the incremental. It waits till it's done and then flips out the whole output. There we go. Got a bunch of nice nifty JSON that we could grab. Like I said, stick it into our Grafana database or our Elasticsearch and go from there. So there you go, bandwidth testing with the iperf3 command on Linux.